I set up Tanner Structural Designs in October 2006. I'm the owner and managing director and the principal engineer as well. Chiefly doing structural engineering of low energy houses, and a large part of that is the insulated foundation systems. We do a lot of timber frame designs, ICF design. We generally leave the traditional kind of construction methods to other engineers. We like to deal with the slightly out of the ordinary stuff. We've been engineering the foundations for KORE from the beginning of when KORE started supplying them, so I think probably around 2009, 2010. The main benefits are from the energy loss point of view. It's much less with the insulated foundation system. You're greatly reducing or eliminating, in many cases, the thermal bridge at the foundation superstructure junction. And there's also benefits for the builders in terms of speed of construction once they're familiar with the system. Traditional foundations, especially for domestic houses, have mostly been designed with rules of thumb, whereas for the insulated foundations, they're all engineered. So we would either calculate the loads on the foundations ourselves or be provided with them. Timber frame companies would usually provide them to us, and then we would use those loads to design the foundation. So we're checking the loads versus the capacity of the foundation and making sure that there's no high point loads or high loads that would cause the foundation system to fail. If we were asked to design an insulated foundation system, we would get the drawings in CAD format. If we have to calculate the foundation loads, we would get the build-ups of the various elements, so the floors, the walls, the roof, so that we can work out where the loads are traveling down to the foundations, and then we can calculate the loads on the foundations. We then check those loads against the capacities. We have done a lot of work in calculating the capacities of various arrangements for the insulated foundations, and we compare those and apply appropriate factors of safety. And if sometimes when there are high point loads, we end up having to put a pad in underneath the foundation with some type of thermal block in between. So we cut out a square out of the bottom of the insulation, the insulated foundation, and put in these thermal blocks to transfer those loads down onto the pad. So we can make that pad as big and reinforce it appropriately as we need to. Just from a workload point of view, we have a lead time, but when we get at it, typically between design and drawings, is probably 2 to 3 days work in a typical domestic foundation. It's a totally different way of building a foundation to traditional. You're coming in with your, I suppose, heavy machinery or your digger and your rollers. You're digging out just a flat platform, unless there's steps in the floor level. You're digging out a flat platform to an agreed formation level, and then you're rolling in layers of certified stone. And it's much easier than having someone walking around between rising walls, blockwork rising walls with a little whacker plate, and you're getting a much better compaction. So you have a much more predictable sub base or base to put the insulation on. So therefore, you end up with less settlement in the long term. And I'm glad to say that in well over 200 foundations that we've designed, we haven't had any problems like that with them. We're able to engineer the foundation systems for pretty much all foundation types. We'll say if you have good ground, as we kind of describe it, good enough for the equivalent of traditional strip footings, that's what we call a standard insulated foundation, and has I suppose, the least amount of reinforcement in it. Then for poorer ground, we can upgrade it to a raft quite simply by leaving gaps between the top sheets of insulation and reinforcing those ribs then in the slab and stiffening up the whole slab. And we've also designed them with piles, so you can just cut holes in the bottom of the insulation to allow the piles to protrude into the foundation, and then incorporate the ground beams that span from pile to pile within the insulated foundation. Now that obviously has a lot more reinforcement. Some people worry about those piles being thermal bridges, which they are, but they're, as an overall percentage of the area of the floor area of the slab, it's very small. But in the odd case where people are very concerned about it, what we've done is we've done the piles and ground beams underneath the insulated foundation, and then put the insulated foundation on top, perhaps with the thermal blocks in cutouts at the bottom of the insulation to transfer the loads down onto the ground beams. A site that kind of sticks out in mind was it was in the very south of England, where the client was wanting the house to appear as if it was floating, and that was also on shrinkable clays where we needed to pile. So in that instance, we did the piles and we created the ground beams underneath the foundation, and then on top of that we put the insulated foundation, and we designed the edge of it to cantilever so that there was this floating effect for the foundation, and it turned out very nice afterwards. A number of builders, they've come back to us who've used them several times, and they'll say they're actually cheaper than traditional strip footings and rising walls. And I think the main reason that they are cheaper is because you can get in with your bigger machinery, and you can get the job done faster. And once you are set up to do it right, it follows a process, and it's very predictable. And as I say, the scale of it with the machinery, it just makes it easy to make quick progress. What convinced us in the first place, back when we started dealing with insulated foundations in 2007, was to certify them, was basically the experience that they have in Scandinavia of using them. So at that time, they had been using them there for 30 years. And when I did research, statistically, the number of failures of insulated foundations was much lower than traditional strip footing foundations. And I would contribute that to the fact that they're all engineered. There's no rules of thumb used. They're engineered, so the likelihood of failure is much, much less. Guarantees, obviously, KORE have now got their agreement cert for the insulated foundation. So that's, I suppose, quite a rigorous process that the NSAI go through to make sure that all the boxes are ticked in terms of building regulations, and just to show that it complies, and that there isn't any, if it's constructed correctly, that it's fit for purpose. The whole engineering process is probably a big difference from their point of view in terms of timeline. So designers like ourselves need to be given time to work out the loads on the foundation and to design the foundation and produce drawings. And whereas if traditional strip footings, people are expecting to just drive into the site with the digger and to start digging and pouring concrete within a day or two. Whereas with the insulated foundations, it's going to be at least a week probably before you pour concrete. But when you do, you've got your floor and your foundation all done at that stage. We have a few customers now who are doing developments more in recent years. I suppose since the housing developments were started up again. Any of them that have worked with it seem very happy with it. I think it's because of the speed that they can build the foundations. One that's just started now the last week or two, and I was on site on Monday, and they've all the stone in for all the bases already for 16 houses, and they have a lovely clean site. There's no muck with strip footings and all that being dug out. So it allows for a nice clean site. They're able to, if another developer, what they like about it is they get a line of houses and they're able to just start at one end and dig the level platform all the way to the other end and put in their stone and roll it. Again, it's just they can get a number of houses done so quickly.